Hello everyone. Uh, Today I will discuss about the friction. It is a small portion of laws of motion in physics. So, have you ever wondered why your car stops when you hit the brakes, or why your shoes don't slip on the ground? The answer lies in a fascinating force called friction. It's a force that opposes motion and plays a crucial role in almost everything we do, like from walking to writing. So in this video, we will explore what friction is, the different types of friction, and we will clear the confusion of use of static and kinetic friction. So let's dive right in. So the friction is the force that opposes the relative motion or the tendency of relative motion between two surfaces, and it's always acts tangentially along the contact, and obviously direction will be opposite of the direction of relative motion. Suppose the car is moving in this direction, so car is moving in the direction, motion will be in this direction. Okay, so the ground will try to oppose this car to move in this direction. So the ground will apply a force tangentially along the contact between this wheel and the ground. It will apply a force that is called the friction force. So let's take a example that will easy to understand the concept of kinetic friction. Concept of friction, that is here, let's say this is the body B, and on that body there is a body A. Now we apply a force on body A in this direction. So body A is moving in this direction. So when body A is moving in this direction, so body B will try to oppose the motion of the body. So body B will apply a force along the tangential along the contact and opposite direction of the relative motion. That is our F. Similarly, when body A is moving in this direction, so body A will see that body B is moving in this direction. So body A is apply a force along the contact, tangential along this contact, that is our F. So body A is applied a force on body B. Similarly, body B is apply a force on body A. So according to the Newton's third law of motion, uh, every force, that means every action, there is a opposite and equal reaction. So according to the third law of motion, the friction is also exist in pair. Okay. Now see the types of friction. There are three types of friction. One is kinetic, one another is static, and another is the rolling friction. Kinetic friction means when there is a relative motion is there. Relative motion is there. That means motion is there. Body uh, is in motion, like you're running, walking, or you can say rubbing hands together, like in this way. The, you rubbing your hands together, that means relative motion is there. The hands is moving this direction with the relative motion. So, and in static friction means there is a tendency of relative motion. Tendency of relative motion. In definition, earlier I said that in definition that is a force that opposes the relative motion or tendency of relative motion. So tendency of relative motion means body is at rest. There is no motion. Like just like I'm holding this pen. So this is the example of static friction. Similarly, there is a bowling of ball bearings. In these cases, rolling friction is applied. So in this video, I will discuss only these two, that is kinetic and static friction. Kinetic and static friction. So let's see first, that is our kinetic friction. So in kinetic friction, you see earlier said that the relative motion will be there. There is a relative motion, and the value of kinetic friction is constant. This does not depend on the relative how much relative motion is there is. Its value is minimum, maximum. It doesn't care about that. So it's always constant, and kinetic friction is denoted by Fk. So Fk is constant. Okay, and on most important thing, that is Fk, kinetic friction is directly proportional to the normal reaction. Kinetic friction is directly proportional to normal. This is very important. So if we remove this proportionality sign, then Fk equals to, we can write like that, is equals to mu k into n, where mu k is a coefficient of kinetic friction. It only depends on the contact surfaces, and in almost in every questions mu k value is given, and it's calculated by experimental. Okay, so in kinetic friction, relative motion will be there, and its value is constant, and the formula of the kinetic friction is Fk is equals to mu k into n. So let's see a problem, so that will be easy for us to understand. So there is a block with mass 4 kg, and we here applied force is given, that is 10 Newton, and in this contact here the mu k value, that is coefficient of kinetic friction value, is 0.2, and assume here assumption, that is the body is in motion. So there is motion is there. So you have to find frictional force and the acceleration of the block. First draw the FBD, that is free body diagram. So the in this direction body would is act, that is 4 into g, and g value is given, that is our 10 meter per second square, and there is a normal reaction in this direction, that is our n. Formula of the kinetic friction is Fk equals to mu k into n, where mu is equals to 0.2 and n equals to 4 into g. If we put this value 0.2 into 4 into 10, then we will get 8 Newton. So in this direction 8 Newton will act. So this is the value of the kinetic friction. Now here n is equals to mg. So Fk equals to, we can write mu k into mg. No, in all cases we cannot write Fk equals to mu k into mg, because when body is in inclined surface, then n value will be different. So n value we can get from the diagram. Now the acceleration of the block, if 8 Newton is acts in this direction, 10 Newton is act in this direction. So if we write 10 minus 8 is equals to 4 into A. So A is equals to 2 by 4, that means 0.5 meter per second square. So we got the kinetic friction force value and the acceleration value, that is a 0.5 meter per second square. Now see the static friction. Static friction means the tendency, there will be the tendency of relative motion. That means body is at rest. And the static friction is variable. Also you can say self-adjusting. Okay. So the value of static friction is denoted by Fs. Okay. Fs. The Fs minimum value is 0 and maximum value is F limiting. And F limiting equals to, write, mu s into n, where mu s is the coefficient of static friction. So Fk equals to, see that Fk equals to mu k into n, and here F limiting is equals to mu s into n, and Fs, there is no such formula because it's a variable, it changes. So there is no such formula, there is a method. So this is the Fs. So Fs is variable, okay, and we got the limiting formula, F limiting formula, that is mu s into n. So let's see another problem, so that will be more clear. Here a block with a mass 4 kg, and here force applied is 6 Newton. Mu s value, that is coefficient of static friction, is 0.2, G value is 10. Find frictional force and acceleration of the block. First draw the FBD, that is free body diagram. So body block weight will be act downward, that is 4 into G, and the normal force will be act upward, that is 10. So first have to see that is body moves or not. So if body moves, then body moves if applied is more than the F limiting, and we know F limiting is equals to mu s into n. Mu s is 0.2, n is 4 into G, so that is 8 Newton. So if applied force is 6 Newton and the friction force in this direction is 8 Newton. So the Fs, that is frictional force value, is 8 Newton. No, it's wrong. In practically, if we think that 6 Newton is in this direction, so if we apply forces 6 Newton, but the body is moving in the opposite direction, it is not possible in reality, in practical. So we cannot say that is frictional force is 8 Newton. In previous you said that static friction value is self-adjusting. So here static friction value will be the 6 Newton. That is the applied force. So here frictional force is equals to the applied force. That is 6 Newton. So Fs value will be 6 Newton. So Fs is 6 Newton, and this is also frictional force will be 6 Newton. So body is at rest. That means there is no acceleration. So acceleration value should be 0. 6 Newton is here. Here it should be 6 Newton. So when this body are the frictional force and applied force is equal to the frictional force, then there is no acceleration. The acceleration should be 0. In this video, what we learned, that is, first we learned what is the friction is, then types of friction, there is our kinetic friction, and there is a static friction and rolling friction. We are mainly focusing on these two in this video. Then we see that in case of kinetic friction, there should be relative motion. Relative motion and value of kinetic friction is always constant. And formula of kinetic friction is mu k into n. And static friction, there is a tendency of relative motion. That means body is at rest and its value is variable. Its minimum value is 0 and its maximum value is F limiting. And F limiting, we write like formula of F limiting is equals to mu s into n. So from this video we learned all those things, and here we learned where we use the kinetic friction and where we use the static friction. When body is at rest, then static friction. When body is at motion, then kinetic friction. So that's all for this video. Thank you.